Hey folks, so in this video, we're going to take a look at how to fix that first limitation, the one about storing strings. So the existing implementation stack that we talked through assumed that we had strings, right? Now I could, if I wanted to, right, I could maybe make a copy of it and put something else in there, right? So I could copy all that source code, I could write in int or double or something else, right? And I'll have a second class called fixed capacity int stack or something like that, right? I could do that, right? That's something you can do, but you can do a lot of things, right? Doesn't mean that you should do them. There's got to be a better way, right? Other than just copy and paste them, right? There's got to be a way to make it more generic, right? It would be nice if I could have one class that I could basically say, okay, this is a class for a stack, and I'm going to tell you what you can hold, right? This would be a great thing. I wouldn't have to copy my code all the time. I wouldn't have to worry about if I have a bug that I fix, I don't have to fix it in this version of stack and this version of stack and this version of stack. It would be nice if it was just one stack and it was generic and I could put whatever I want into it. So what do we want to do? Well, we want to use Java generics, so which is interesting, right? I was using the word generic during its traditional usage, but generic is generic, right? Is a term used in Java as well. It's a very specific Java term. If you want more information, you Google that, right? Java generics, and it'll pop up. So Java generic has the idea of what we call generics. So a generic is maybe an unknown type. So normally when you write your program, you know all of your types ahead of time. You know this is an int, this is a float, this is a string, et cetera, et cetera. You know your types in advance. Well, sometimes we don't really know what the types are in advance, right? Particularly when devising things like containers, right? Do I want this to be a container for strings? Do I want this to be a container for ints? I don't know off the top of my head, right? I don't know yet. And I don't want to end up having to have multiple versions of it. And so it gives us syntax like this, right? So instead of just having like a class, we'll say that a class uses a generic, right? So I can see I have basically this would be like the name of a class, and here I would have special bracket things, right? The less than greater than. And inside of those arrows, those bracket things, arrow things, that would be like a type that I haven't talked about yet. And we'll see what this looks like in a second, right? So slides, right, it says, let's the programmer use type as a data type in the definition of the class. So let's just look at the example. This is a very, 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 very simple class. It just has two things in it, two variables called value and next. Node, right, is presumably a class that's defined somewhere. That's fine. But what's interesting here, right, is the following. Notice that in these little arrow things, I have the word element. Over here, I also have the word element. These two are related, okay? So when I use element in the body of my class, when I'm using generics, right? And generics, I know that I'm using them because of the arrows, right? That's what the arrows mean. It says this is a generic variable type. When I use a generics word inside of a class, it's effectively a placeholder. It's me saying, oh, this class is going to use this type called element, but I don't really know what it's going to be like exactly. And so maybe even a little bit more code over here, right? Let's say we were trying to create an instance of this class, right? It looks like this: x equal some class of int new some class. I'm forgetting my Java here. Y equal new some class of string, right? So here, right, rather than just saying, oh, x is equal to new some class, open close parentheses, and close it with a semicolon, I have this bit here where I have these arrows and then a type in the middle. What happens is that when the compiler sees this code, right, it sees that, oh, hey, I see the arrows, he's using generics for this class, and it goes and it looks over here and says, oh, hey, the generic is called element. So element is effectively a placeholder. And so when you compile your program, it actually takes this int thing here and it substitutes it in for element, right? The element there as well as the element over here, right? So basically you say this, build me some class for int, right? And that means look at the generic, which is element, and every time you see generic, replace that by int. I could do the same thing over here, right? If I had this str, the string one, right? The string one, these should be in more angular things. The string one, basically element will be replaced by string all over the place, right? Kind of a different but similar, right? It's the same mechanic, but we're using it to do a different thing, right? We're replacing it by int in one case, replacing it by string in another case. Overall, the idea, right, is we have a placeholder, right? So wherever I see element in my class, the compiler will go in there and replace it by what I really want when I go to compile it, right? And so instead of having to have a different version for int and a different version for strings, the compiler will basically take care of it behind the scenes. It'll automatically build that, which is a very nice thing. All right, so this is the basic idea of generics, right? Basically, it's a variable that you can use in your class, and you don't have to define it up front. You can define it some other time in your program, right, when you go to use the class. Some final notes here. First of all, is that when you do generics, you're limited to nullable types. Basically, what that means is this. It shouldn't be integer here. Right? This shouldn't be in here. It has to be integer, right? I can't put a primitive type here, right? These can't be primitive types. Those have to be object types. They have to be nullable types. This is just a Java rule. Don't worry about it too much. Just know that you have to use some sort of an object. So like an int, you can kind of get around a little bit by using integer, right? So there's a container or a wrapper class that we can use to get around it. But in general, it has to be an object type. It can't be a primitive type. As the last note here, Java is annoying, and you'll see what I mean on the next slide. All right, let's actually go ahead and move forward. So this is going to be actually our implementation with generics. So on the left-hand side, I have our original stack. On the right-hand side, I have our new updated stack as well how it's used. Take 1 second and try to see if you can figure out what are the differences between the left side and the right side. What are the differences in that stack implementation? What's changed? So let's take a look at the left-hand side. What's changed there? So think back maybe to the source code for the original, right? You can bring it up if you want, but what's changed? Well, the differences over here are the following. First of all, right, we lost the word, we used to have the word string in there, right? That's gone. Now we have this. This says that you are a class that uses one generic variable of type, uses a generic type. I shouldn't say variable, uses a generic type. Uses a generic type called item. So it's there. That's one change. I had to add that there. Over here, instead of having string, I now have item. Over here, when I build it, I now have item as well. When I push, I have item as well. When I pop and return, I have item as well. So those are the different places that change. Basically, every place I had string in my original example, my very simple stack implementation, is now replaced by item, right? So item is a new variable type that's available. It's a generic, right? I just substituted there wherever I had the other one before. Okay, so that's us implementing in generics. Pretty simple, right? Again, just think we're going to basically, actually, we can go look at the right-hand side. So the right-hand side is actually an example of how this works in practice. So when you go to use your generic class, what happens is you type stuff like this. You go fixed capacity stack equal new fixed capacity stack, and then the arrows, right, of integer, right? A nullable type. We'll put in the arrows to indicate this is the generic. So that's how you use this thing, right? And we would put string in there, right, if we were reduplicating the one from before. And what happens is Java actually takes this stuff over here and generates code for it. So it changes and rewrites that line to look like this. So it has a new stack, and they add some junk at the end to make it because you could have, if you use a stack with different types, you'll have to create a new stack for each of them. So it just adds some sort of a prefix or suffix to kind of distinguish them. Anyways, so it creates a new stack, right? And it basically goes and substitutes in, right? So any place that you saw item, it substitutes in integer, right? So you can see integer appeared here, integer, right? So it actually does that copy-paste operation of building this new class and putting in that type that you want, right? That's a very nice thing, right? So how you do it yourself, now Java's doing it. All right, so you can see there, right? That's kind of how it looks, right? When you use this, new generic stack to store integers, right? And it looks similar with strings, right? But I'll have strings, right? Instead of integer. All right, so things look good. We've gotten our first limitation. We've fixed our first limitation, right? We have release stacks now that can store anything. All right, so this is our first upgrade. And the next video, we'll continue with our continuous improvement of the stack.